Burj Khalifa, the tallest man-made structure on Earth, reaching an astonishing height of 828 meters, or about half a mile into the sky. It stands as a symbol of human ambition, innovation, and the power of engineering. But how exactly was this incredible tower built? How did architects and engineers overcome the immense challenges posed by its height, location, and the harsh desert environment? Today we're going on a journey behind the scenes, from the vision that sparked the project to the final moments when the spire was placed, and everything in between. Our story begins in the early 2000s, when Dubai was a city on the rise. Once a modest trading port on the Arabian Peninsula, Dubai had begun transforming itself into a global hub for commerce, tourism, and luxury. Sheikh Mohammed bin Rashid Al Maktoum, the ruler of Dubai, envisioned a landmark so extraordinary that it would place Dubai firmly on the world stage. The idea was to build the tallest building ever, not just for height, but as a beacon of progress and possibility. The project was initially called Burj Dubai, meaning Dubai Tower. The development was led by Emaar Properties, a prominent real estate developer in the region. However, during the financial crisis of 2008, the project faced economic difficulties. To help support the completion, Abu Dhabi's ruler Sheikh Khalifa bin Zayed Al Nahyan provided financial aid, leading to the tower's renaming as Burj Khalifa in his honor. Designing the Burj Khalifa was no small feat. The architectural firm Skidmore, Owings & Merrill, based in Chicago, was selected for the job. Their lead architect, Adrian Smith, had a remarkable resume, having worked on other record-breaking skyscrapers like the Willis Tower in Chicago. The design was inspired by the native desert flower called the Himenocalyx, which has a beautiful, intricate six-petal form. This floral inspiration was translated into the tower's Y-shaped floor plan, which provides both aesthetic appeal and structural advantages. This Y-shaped base was not just about looks. It provides exceptional stability, helping the tower resist the powerful desert winds that can buffet a building hundreds of meters tall. The tower's shape tapers gracefully as it rises, stepping back in a spiraling pattern that reduces wind loads and vortex shedding, which can cause dangerous swaying. This tapering is not only beautiful, but essential to the tower's stability. The foundation of the Burj Khalifa had to be exceptionally strong to support the immense weight of the tower, especially considering Dubai's challenging soil conditions. The site consists primarily of loose sand and weak rock layers. Engineers designed a raft foundation, nearly 4 meters thick, which spreads the building's weight over a large area. Beneath this raft are 194 board-reinforced concrete piles, some extending as deep as 50 meters into the earth, anchoring the structure firmly. Each pile was extensively tested to ensure it could bear the load. Given Dubai's intense heat, pouring concrete was a challenge in itself. Concrete can crack or cure improperly if exposed to extreme temperatures. To combat this, engineers poured concrete only at night when temperatures were cooler. They also mixed ice flakes into the concrete to lower its temperature and ensure a strong, durable foundation. Construction officially began in January 2004. The main contractor was Samsung C&T, a South Korean company renowned for building Taipei 101, which was then the tallest building in the world. The Burj Khalifa's structural system centers around a reinforced concrete core that acts like the building's backbone. Using a technique called jump forming, the construction team was able to rapidly raise the concrete core, completing one floor every 3 days. Pumping concrete up the tower's height was another enormous challenge. To do this, the team developed the world's highest concrete pumping system, capable of pushing concrete up to 605 meters, a record-breaking achievement at the time. This innovation ensured that construction could proceed quickly and safely without compromising quality. The tower was topped out in January 2009 when the spire was placed, reaching the full height of 828 meters. But the engineering challenges didn't end there. It is one of the greatest threats to super tall skyscrapers. At these heights, winds can reach speeds over 200 kilometers per hour. To understand and counteract wind forces, the design team performed more than 40 wind tunnel tests, using scale models to simulate conditions and optimize the shape. The spiraling setbacks of the tower disrupt the wind flow and reduce vortex shedding, preventing violent swaying. Despite this, the building still sways gently, up to 1.5 meters side to side, but in a controlled and safe manner that absorbs wind energy without damaging the structure. The harsh climate of Dubai posed another set of challenges. Summer temperatures regularly exceed 50 degrees Celsius, with intense sunlight beating down on the tower's surface. To combat heat, the building's exterior cladding is made of reflective aluminum and textured stainless steel panels, combined with over 26,000 hand-cut glass panels designed to withstand extreme temperatures while allowing natural light inside. This facade not only protects the building, but also helps maintain energy efficiency by reducing cooling loads. Getting people to the top of the Burj Khalifa required an extraordinary elevator system. The tower has 57 elevators and 8 escalators. Because no single elevator can travel the entire height of the tower, a zoned system is used. Express elevators travel to sky lobbies, where passengers transfer to local elevators serving individual floors. These elevators are among the fastest in the world, moving at speeds up to 10 meters per second, whisking visitors and residents rapidly through the building. Inside the Burj Khalifa is a city in the sky. It contains luxury residences, office spaces, the Armani Hotel, restaurants, fitness centers, and observation decks offering breathtaking panoramic views of Dubai and beyond. Every system, from plumbing to air conditioning, was designed specifically for the unique challenges posed by the tower's height and desert environment. The construction effort involved over 12,000 workers from more than 100 countries. Teams worked around the clock to meet tight deadlines while maintaining stringent safety standards. The Burj Khalifa set new records and standards for skyscraper construction that will influence architecture and engineering for generations. In the end, the Burj Khalifa stands as more than just a building. It is a monument to human creativity, determination, and technological mastery. Rising majestically above Dubai's skyline, it reminds us that with vision, innovation, and perseverance, we can push the boundaries of what's possible and reach unimaginable heights. Subscribe for more.